Hello viewers, welcome to my channel. I'm Hasham. Now I'm going to start the problems on sampling, statistical sampling. Already 3 videos I have prepared on the theory of sampling. I have explained you what are the basics of sampling, what is the procedure of sampling, what are the methods, random and non-random methods of sampling, then parameter and statistic, then determination of sample size, hypothesis testing, what is the procedure of hypothesis testing, then estimation, statistical inference. Inference consists of what are the conclusions we are making by sampling. So there are 2 types of problems called estimation problems and hypothesis problem. Estimation problem where we don't have any information about the population and we are studying the sample and deciding what would be the information about the population. Estimating the information about population parameter. That is called estimation. Again, estimation we have point estimation, internal estimation. Then hypothesis testing. The meaning of hypothesis is an assumption or statement about population parameter. So before conducting the sampling test, we will have in mind some statistical measure of the population parameter. Keeping in mind, we want to check, we want to prove so whatever population parameter is there, that is true or not true. That is called hypothesis testing. So majority of problems are on hypothesis testing only. All these things I have already explained in the last 3 videos. Now I am going to start the problems. There are different statistical techniques, sampling techniques available called Z-test, T-test, chi-square test, ANOVA, etc. Many tests are there, but for our syllabus purpose, I am considering only 4 tests: Z-test, T-test, chi-square test, and ANOVA. So before watching the problems, a student must be conceptually clear regarding the concepts which are used in sampling. Example, what is population, what is sample, what is population parameter, what is sample statistic, what is hypothesis, and what are the steps involved in hypothesis testing. Without understanding the theory, you should not come to the problem. Otherwise, it will be very difficult for you. So, follow my suggestion. If you want the complete grasp on the subject, first you watch the theory videos, then you come to the problems. So, first of all, Z-test and T-test. Z-test is called large sample test. When a sample is said to be large, if the sample size is 30 or more, so whenever the sample is 30 or more, we apply Z-test. If the sample size is below 30, it is called small sample, and there we apply T-test. After completing Z-test, we'll discuss about T-test. Right now we concentrate only on large sample test, that is Z-test, where sample size is more than 30. Right? So before starting the problem, I expect my viewers to take a printout of the problems which I have given in the link under my description. So always keep ready the problems printout and then watch the video. Take a screenshot of the solutions of the first 2 problems on Z-test. Come on. See the first problem, very first problem. A company market car tires. Their lives are normally distributed with a mean of 40,000 kilometers and standard deviation of 3,000 kilometers. A change in the production process is believed to result in better product. A test sample of 64 new tires has a mean life of 41,200 kilometers. Can you conclude that the new product is significantly better than the current one? Understanding the problem is half solved. So before going to the solution, try to understand the contents given in the problem. A company markets tires. So the life of the tire is 40,000 kilometers. So on an average, each tire will go for 40,000 kilometers. The life is 40,000 kilometers. And the standard deviation is 3,000 kilometers. This is the population. Because all the tires have an average life of 40,000. So this 40,000 is the population mean. Population means whole. All the tires. The population mean 40,000 kilometers and population standard deviation 3,000 kilometers. A change in the production process. Now the company is changing the production process. New technology is applied in producing the new tire. The company believes that after bringing the change in the production process, the life of the car tire will increase. That is the contention of the company. So correspondingly, the company has changed the production process. After changing the production process, it has taken a sample of 64 new tires. And this sample of 64 new tires have shown a mean life of 41,200 kilometers. Apparently, without applying any test, we can compare before production change, before the change in the production process, the car tire was 40,000 kilometers. Life of the car tire was 40,000. After change in the production process, we can check, here it is given 41,200. So apparently it looks like the life of the car tire have increased. Apparently. But is it definitely surely increased or not? We don't know. So for that purpose, we are applying hypothesis testing. Sure, definitely the car tire life has increased or not. So can you conclude that the new product is significantly better than the current one? Ultimately the question is, it is asking you, can we conclude that the change in the production process has increased the life of the car tire or not? That is the question. So we apply hypothesis testing because already we have in mind what is the population measure. 40,000 kilometers. 40,000 kilometers is the population mean, right? We want to check whether it is increased to, from 40,000 or not, or it remains same. This is the first problem. See carefully. What are the steps? We assume the population is normal. So for applying the Z test, always you have to make some assumption. First assumption is we are assuming that the population has a normal distribution. Secondly, the observation are drawn from the population independently. That means random samples have been taken independently. So these two are the assumptions we are making for applying the Z test. Now say further, since n is greater than 30, because the sample size given in the problem is 64, it is more than 30. The sampling distribution of mean may be considered as approaching the form of normal curve. When the sample size is more than 30, then we assume that it will follow normal distribution and we apply normal curve. So normal curve will be applied only if the distribution, if the sample size is more than 30. So these are the assumptions. Even if you don't write this assumption in examination, it will be okay. This is the first problem. For your information, I am writing this observation assumptions. Now we are given, so whatever data given in the problem, I'll put down. N. N stands for sample size. Always in all the coming problems, N stands for sample size. Here the sample is 64 tires. X bar. These are the notations I have already explained in the theory video. Population parameter and sample statistic. The statistical measure of population are called parameters and the statistical measure of the sample are called statistic. So different notations we will use. X bar. X bar is the sample mean. Always, not only in this problem. In all the coming problems, wherever X bar comes, you should think it is a sample mean. So sample mean is given 41,200 kilometers. 64 tires of sample have been taken and this 64 tires have shown an average life of 41,200. Mu. Mu is the symbol for population mean. Always in all the coming problems also. Mu is the population mean, X bar is the sample mean. The population mean, what is the average life of all the tires produced by the company? 40,000 kilometers. And sigma is the standard deviation of population. These are the notations we have to use. Sigma is the population standard deviation. It is given in the problems, 3,000 kilometers. This is the complete data given. Now we apply the steps. In the last video, theory video, I have explained you there are 5 steps in hypothesis testing. 5 steps. The first step is laying down of hypothesis. The 2 hypotheses you have to specify. The 2 hypotheses are null hypothesis and alternative hypothesis. Null hypothesis is denoted by HO, here you see. And alternative hypothesis is denoted by H1. The meaning of null is no difference. Meaning of null is no difference. No difference between population mean and sample mean. Population mean and sample mean, no difference at all. Even after changing the production process, the average life of car tire remains same. That is the contention of null hypothesis. So in the coming every problem, when we write null hypothesis, immediately you should think no difference. No difference between the population parameter and the sample statistic. So here, null hypothesis mu is equal to 40,000 kilometers. And there is no significant difference between the population mean and sample mean. There is no change in the life of tires. So in null hypothesis, always we should write there is no difference between the population mean and the sample mean. And whatever change in the production process has been done, it has not increased the life of tire. That is the null hypothesis. Now alternative hypothesis will be exactly opposite what we have written in null. In null we have written there is no change in the life. The alternative, there is change in the life. There is change. Change means increased. Because here you can see before change in the production process it was 40,000. After change in the production process it has become 41,200. So what do you observe? There is increase. There is increase. So here null hypothesis, no change, no increase. Alternative hypothesis, yes, there is increase. There is increase. Increase means it is more than 40,000. More than 40,000. So alternative hypothesis H1 mu greater than 40,000 kilometers. When we write the symbol greater than, it's a right-tailed test. It's a right-tailed test. I'll explain you what is right-tailed here. So here, alternate. The life of the car tire increased after the change in the production process. So 2 hypotheses we have to lay down. First null, second alternate. Null hypothesis, there is no change in the life of the car tire even after changing the production process. It is remaining same, 40,000 kilometers. This is null. Alternative hypothesis opposite. Yes, the life of the car tire has increased after the change in the production process. The new car tire is better than the old one. That's it. Now second step, level of significance. Level of significance is the risk which the experimenter is taking in conducting this sample. Normally the risk will be given in the problem. Level of significance will be denoted by alpha. Level of significance always will be denoted by alpha. It is a risk taken by the experimenter. So what type of risk? His conclusion may go wrong. Because whenever we conduct sampling, it is not 100% correct. There is some risk. So when we say 5% risk, it means 95% the experimenter is confident in his decision. And 5% his decision may be wrong if it is 5%. In our problem, level of significance is not given. So I am assuming. So normally what are the assumptions? 5% or 1%. You can assume even other percent also, 10% or 2% like that. But normal assumption will take either 5% or 1%. So I am taking it 5%. 5% means 5 by 100. 5 by 100 comes to 0.05. Assumed. If it is given, we would have written given. It is not given, assumed. Two steps only. The first step, null and alternative hypothesis. Second one, level of. Third, test statistic. Here we have to apply the formula to calculate the computed value of Z. Formula to apply to find out the computed value of Z. So since the sample is large, because it is more than 30, the sample size is 64. It's called a large sample. So since the sample is large, under HO, under null hypothesis, the test statistic is Z. The test statistic is Z. So this you have to explain that I am applying Z test because the sample size is large. So Z is equal to formula x bar minus mu divided by sigma by root n. Remember the formula. Sigma by root n. Now I am substituting, all the values are given here. So x bar is 41,200, mu is 40,000, sigma is 3,000, n is 64. So 41,200 minus 40,000, 1,200. So 3,000 divided by 64 under root is 8. So 3,000 by 8, 375. So 1,200 by 375, 3.2. 3.2 is called computed value of Z. Computed value of Z. Now this computed value of Z should be compared with the critical value of Z. Critical value means stable value. Next step. Step number 4. Critical region. At 5% level, the critical region depends on two things. The first thing is level of significance, and secondly, alternative hypothesis. In alternative hypothesis, whether you are taking one tail or two tail. Some problem one tail, some problem two tail. Right now it is one tail because right side, right tail test. The tail is there only on the right side we are taking the tail. Left tail we are not taking. That's why it is called right tail test. So here at 5% level of significance for right tail test, the table value of Z is 1.65. Now you will get confused how we got 1.65. I will explain. So 1.65 is the critical value or table value. Thus the critical region consists of all values of Z greater than or equal to 1.65. Because it is a right tail test. 1.65 is the critical value. But whether this 1.65 is on left side or right side, because we have two tails. In the curve we have two tails. This is the left tail, this is the right tail. Because it is a right tail test, so all the values greater than 1.65 will go in critical region. Remember, critical region means rejection region. And non-critical region means acceptance region. I have drawn a curve here. In this is a shaded area. This shaded area is called rejection region. This shaded area is rejection region. This unshaded area is acceptance region. Unshaded area is acceptance region. Now we have to see whether this 3.2 will lie in acceptance region or in rejection region. Then we can give the decision. Now first of all, you must know how we got 1.65. Now I am going to explain you. This is a normal curve. Normal curve is a bell-shaped curve where the total area under normal curve is 1. 0.5 area left side, 0.5 area right side to the perpendicular. So in this curve, one perpendicular is drawn. 50% area left side, 50% area right side, 0.5 area, total area. From middle to infinity, it is 0.5. Now what is the percentage we have taken level of significance? 5%. So 5% is the level of significance. So here this shaded area 0.05. 5%. Right? So this 5% is the shaded area. In the middle, mu is equal to 40,000. The average is 40,000. Mu is equal to 40,000. And Z is equal to 0 always. Now we need this area. This unshaded area. The total area under the normal curve is 1. 0.5 area left side, 0.5 area right side. So left side, this area is 0.5. We don't require. right side 0.5. From 0.5, how much is the shaded region? 0.05. So direct 0.5 minus 0.05, you will get 0.45. So this unshaded region is 0.45. Now we need what is the value of z for this x is equal to 41,200. For x is equal to 41,200, what is the value of z? Now you have to refer the area table. In any textbook of statistics, you will find area table. And also in the link, I have given one PDF for this area table. You can take a printout of this area table. By referring this area table, we can get the value of z is 1.65. It will not be given in the problem. You have to refer the area table, z table, right? Now, 0.45. Total area is 0.5. 0.5 minus 0.05 is 0.45. Now, these values, the body of this table will have all areas. In this area, locate 0.45. So, if you search 0.45, you will not get exactly 0.45. You will get 0.4505. If you carefully observe, you will get 0.4505. That value is very near to 0.45. Value is very near to 0.45. So where is this? In which row and which column we have 0.4505? So if you watch carefully, you will get in the row 1.6. 0.4505 you will get in the row of 1.6 and in the column 0.05. Column 0.05, row 1.6. So here I have written, if you refer the area table, the area is 0.4505 against the row 1.6 and under the column 0.05. Hence the critical value is 1.65. That is 1.65 I have taken here. The critical value is 1.65. Now two values we have. Computed value 3.2. Critical value 1.65. Now final decision. How to give the decision? The computed value of z is 3.2. Here is the computed value. The computed value is 3.2. Is much greater than the critical value z 1.65. The critical value we got 1.65 here. Whereas computed value is 3.2. Now tell me 3.2 is greater than 1.65 or less than 1.65? 3.2 is greater. 3.2 is greater than 1.65. Is much greater than critical value 1. So computed value falls in rejection region. See here, this is the rejection region. 1.65 and more than 1.65 will go in rejection region. Less than 1.65 will come in acceptance region. Our computed value 3.2, which is more than 1.65, so it falls in rejection region. Critical region is the rejection region. This is the critical region. Right? So here, so the computed value falls in rejection region. We reject the null hypothesis. When it falls in rejection region, we are rejecting the null hypothesis. What is the null hypothesis? Says no significant difference in the average life of car tire before and after. That we are rejecting. So when we reject the null hypothesis, we should accept the alternative hypothesis. What is the alternative hypothesis? The life of the new tire is increased after the change in the production process. This we accept. Null hypothesis we have rejected. Alternative hypothesis we will accept. So this second contention we accept. That means the life of the new car tire is better than the life of the existing one due to the change in the production process. We reject the null hypothesis and accept the alternative hypothesis and conclude that the life of the car tire increased after the change in the production process. That's it. This is the first problem on Z test. Similar, I have explained you in much detail. In the next problem, I am not going to explain that much detail because the same steps will be applied. Now, next problem number 2. An educator claims that the average IQ of American college student is at most 110 And that in a study made to test this claim, 150 American college students selected at random had an average IQ of 111.2 with a standard deviation of 7.2. Use a significance level of 0.01 to test the claim of educator. Exactly similar to the previous one. An educationist is claiming that American college students' IQ is at most 110. What do you mean by at most 110? Maximum 110. Not more than 110. It may be less than 110 or up to 110. That is called at most 110. This is the contention made by the educator. Average IQ level of American college student at most 110. Right? To test his claim, we have selected a sample of 150 students, American college students, and tested the IQ. So 150 student is the sample, and the test IQ level has come to 111.2. So apparently it looks like the IQ is more. The sample IQ is more than the population. That means the educator's claim is not correct. He is claiming only up to 110, but sample says it is more than 110, and with a standard deviation of 7.2. Now level of significance is given 0.01. Previous problem level of significance was not given, so we have assumed. Now it is given, so we'll write on whatever is given. 0.01. 0.01 means 1%. That's it. Now the solution looks like we are given. I am not writing all these assumptions. This is the first problem. That's why I have written the assumption. In examination, you can write or you can ignore also. Not compulsory. Now we are given sample size. What is the sample size? How many students selected? 150. Then mu. Mu means population mean. The educator claim at most 110. So mu is less than or equal to 110. Population mean. Mu is equal to at most 110. Means less than or equal to 110. Then x bar, sample mean. The sample mean is given in the problem 111.2. And sample standard deviation. Previous problem sigma was given. Population standard deviation was given. But in the current problem, the standard deviation of the sample is given. So it is denoted as small s. Small s is the sample standard deviation and sigma is the population standard deviation. That you have to remember. Notation. This is the information given. Alpha is equal to 0.01. Null hypothesis. First step, laying down of hypothesis. Null hypothesis. No significant difference between the population mean and the sample mean. Whatever educator is claiming, that is true. He says at most 110 means 110 only. Not more than 110. It is less than or equal to 110. No significant difference between population and sample. Mu is less than 110. The average IQ level of students are at most 110. That is not more than 110. Not more than 110. That is the null. Alternative opposite, ulta. When it is saying less than or equal to 110, alternative means it is more than 110. Opposite. So here mu is greater than 110. The right tail test, because greater than sign is there, it is called right tail test. I told you in the previous one. Now, the educator's claim is not correct. Alternative hypothesis, we are saying educator's claim is not correct. Here, null hypothesis, you should write a sentence. The educator's claim is correct. The average IQ level of American college students is at most 110, not more than 110. Alternative, more than 110. That means educator's claim is not correct. The average IQ level is more than 110. Then level of significance, alpha 0.01 given. Test statistic. Since the sample is large, under HO, the test statistics is Z. Same wording what I have written here. Apply the formula, Z is equal to x bar minus mu. X bar minus mu divided by sigma by root n. But we are not given the sigma. Sigma stands for population standard deviation. We are not given population standard deviation. We are given sample standard deviation. Right? So here one sentence. For large samples, we can substitute S in place of sigma. One point you have to remember. If the population standard deviation is not given, we can substitute with sample standard. So if population standard deviation sigma is not given, we can substitute small s in place of sigma. The formula we will change. In place of sigma, I can write S. When I can write, if in the problem population standard deviation is not given, we can change it to sample standard deviation. Divide by root n. So x bar is 111.2, here it is 111.2, and mu is 110. Divide by small s is 7.2, here it is. Divide by under root n, n is 150. So 111.2 minus 110 is 1.2. Divide by 7.2, divide by 150 root. 150 root comes to 12.247. So 7.2 divided by 12.247, you will get 0.588. So 12 divide 1.2 divided by 0.588, you will get 2.04. This 2.04 is the computed value of Z. Computed value of Z. Now we need the critical value. Critical region. At 1%, previous problem it was 5% level. But now it is given in the problem 1%. So at 1% level of significance for right tail test, the table value of Z is 2.33. There at 5% we got 1.65. 1.65. At 1% level of significance it is coming to 2.33. How 2.33? I'll explain. Does the critical region consist of all values of Z greater than 2.33? Because it's a right tail test. Because here greater than sign means rejection region will lie on right side. So all the values which are greater than 2.33 will go in rejection region. Greater than 2.33. How we got 2.33? In this diagram I am showing. Normal curve. The total area under normal curve is 1. 0.5 area left side of perpendicular and 0.5 to the right side of the perpendicular. Right? Now rejection region is 1%. The level of significance is 1%. So here rejection region is the shaded area. This shaded area is the rejection region 0.01. 1%. Now 50% from this perpendicular right side 50%. 50% means 0.5. So 0.5 minus 0.01, you will get 0.49. So this unshaded area is 0.49 area. Now you have to refer the area table. This is the area. In this area table, in the body of this table, all the areas are given. Now you locate 0.49. Locate where is, in which row and in which column you will get 0.49. So exactly 0.49 you will not get. The nearest value to 0.49. So you will find there 0.4909. 0.4901. You will get 0.4901. So against the row 2.3. If you will look at that, against the row 2.3 and in the column 0.03. Row 2.3 and column 0.03. So the critical region comes to 2.33. Here I have written. If you refer the area table, the area is 0.4901 against the row 2.3 under the column 0.03. Hence the critical value is 2.33. That's it. This 2.33 I got it. Now decision. Finally, compare the computed value with the critical value. Computed value is 2.04. Whereas critical value is 2.33. That means any value more than 2.33 will go in rejection. Any value below 2.33 will fall in acceptance region. Here the value is 2.04. It is less than. 2.04 is less than 2.33. So it falls in acceptance region. The computed value of Z 2.04 is less than the critical value 2.33. So it falls in acceptance region. Null hypothesis is accepted. Previous problem, it falls in rejection region. The computed value 3.2 is greater than 1.65. So it falls in rejection region. But here the computed value 2.04 is less than the critical value 2.33. So it falls in acceptance region. When it falls in acceptance region, we accept the null hypothesis. Whatever null hypothesis we have written, that will be accepted, and alternative hypothesis rejected. So what is the null hypothesis we have written? that the educators claim that American college student IQ is at most 110, not more than 110. That we'll accept. It is not more than 110. The alternative hypothesis greater than 110, reject. So finally, the educator's claim is correct that IQ level of American college students is at most 110. That's it. So these are the first two problems. That why I have explained in detail. In the coming problem, I will not explain. I will not use so many words to explain because already you are aware about these two. But remember, the problems are different. Don't think that all Z test problems are this only. No. Here we are comparing the population with the sample. In the next video, I am going to compare two different samples. Then two different proportions. So varied type of problems. So if you want the complete command, if you want to be confident on this topic, watch all the videos. Don't watch only one video and think that that test is over. No. Different problems I am going to do in the next video, inshallah.